This is problem 4, manipulating vectors with trigonometry. Two cowboys have roped the bull. They're pulling on it as such, 750 newtons, 40 degrees to the left of the vertical in the diagram, 1000 newtons, 25 degrees to the right. What is the force the ground is exerting on the bull? The bull is stationary, so the force of the ground on the bull must be upwards in the diagram. Something like this. Something like that. We're not sure where it is. We can calculate it. So the way we calculate it is by breaking the forces from the cowboys, these two cowboys, left and right, into their components, the horizontal and the vertical components. The left to the right is right here. That's the side opposite 40 degrees, so we use sine. This component is 482 newtons. And the right cowboy in the x direction is right here. That's the side opposite, so we use sine 25 degrees and we calculate this is 423 newtons. The vertical component from the cowboy on the left is cosine 40 degrees times 750, which is 575. We put a negative sign on it because it's downward, but we can see it's negative from the diagram. The cowboy on the right in the vertical direction is 906 newtons straight down. Now, let's put these on the diagram. There's the triangles, there's the right triangles. We can get the components with trigonometry. And once we put the components on the diagram, we should get rid of the vectors because it's either one or the other. Now we can see what's going on. That's the whole purpose, to make it easy by getting the components. The bull is stationary. There's no net force in the east-west direction. There's no net force in the north-south direction. The net force on the bull from the cowboys in the east-west direction, horizontal, is 482 this way, 423 that way. That's 59 newtons to the left. Since the bull is not moving, the force must be 59 newtons to the right from the ground on the bull. Now we can do the vertical direction. When you do vectors, you do one direction at a time. The net force on the bull from the cowboys in the north-south direction is 575 plus 906, which is 1481. And it's downward. So the ground must be pushing the bull 1481 newtons upward in the diagram. The problem asks for the force the ground is exerting on the bull. It's a vector. Our answer should be a vector. We can report the components. About 60 newtons to the right and about 1500 upwards. We can calculate the magnitude and the direction. The magnitude is going to be about 1500. We can use a Pythagorean theorem. And that's what it is. And to get the direction, we use arctangent. Tangent is opposite over adjacent. The opposite side is, we're going to use this angle here, is 59 newtons. And the adjacent side is about 1481. And we calculate this angle is 2.3 degrees. So we say 2.3 degrees east of north. When solving problems with vectors, a good diagram is crucial. It prevents careless mistakes and provides a first principles understanding of what's going on, and that's the goal. First principles understanding.